can see it later. Oh, we've got Bob coming on. So, hello and welcome to October's Solar Chat. And it's lovely to see you all, and it's great to see everyone from all around the world, especially those who are getting up so early in Australia. You know, you're such wonderful souls for getting up. We've got a few questions that everyone wanted it, mainly from Peter and from Nick. So I was sort of like thinking that maybe the prominence part might go on a bit. So should we start with Nick's question and go through that first, I think, before we get lost completely in the prominences.
Sounds good.
Hi, Bob.
Yeah.
Welcome.
Hey, Bob.
So
Ivan snacking too, I see.
oh yes.
Hi, Ivan's there.
Welcome, Ivan.
Hi to all.
Hi. So it's all the great crew that have joined. Right, okay, so Nick's question was about language and terminology that we use with describing particularly like solar features, like when people say, oh, I've imaged a spot. And when you're looking in hydrogen alpha, is that really a spot, or is it the atmosphere above a spot? Or are we imaging an active region, or does it really matter what we're saying? Because we are all amateur solar astronomers, or should we be using the correct terms? And should we, if somebody uses the wrong term, sort of like chastise them and say such and such? Or does it really matter? So that was Nick, and if you've got anything else to add, Nick, then yeah, do so.
Yeah, I think it's born of now I'm in a situation where I'm imaging in G band and calcium K, and an endeavour to be in sometime in the next decade imaging in hydrogen alpha. I suppose it's about the science behind it and and it's now become a thing to me. Well, which of those three lights are you using to feature and concentrate on which structures? So in my mind now, a little bit for in times gone by, I would quite easily have said, here's a sunspot in hydrogen alpha. But now I'm thinking, when I image in G band and its photosphere, that's taking a photograph, that's imaging the spot, I think. And then when you're looking at a spot in hydrogen alpha, it's the atmosphere above the spot, as per the question. And where you don't want to become so pedantic that it's, stealing someone's thunder or dampening their fire or passion for it, is it correct? And if it is correct, then why bother trying to image the photosphere in white light? So I think it's, as my understanding and experience has developed, then the language become more important. It's not necessarily to chastise others that are using that language, or and then similarly, I've imaged a CME. Well, do you pick up a CME in calcium, for example, or are you imaging the prominence that's a prominence that's not got a CME, or is it the prominence that you're imaging as a result of a CME? But you can't say, I don't think, but it could be my lack of science and inexperience in this, that you are imaging a prominence in calcium. So that's more about learning about the three different wavelengths. So it was just, what do others think? Is it important, or should I just forget about it and get on with it? It's not to chastise anyone. It's more to develop my own vocabulary, I think, because the more I interact with people online, the more I think I ought to be getting it right, really, because I don't want to perpetuate poor vocabulary, if you like. So yeah, what are people's thoughts?
So I think a lot of newbies make the mistake of thinking prominences are flames, so clearly, that's incorrect. So I think we've got to be correct as far as we can be within reason, if you see what I mean. So we should call them the right things. The question then, I guess, from you, Nick, is, well, what are those names for those particular objects that we can see in the different lights? So maybe we could have a glossary or something in the library, a document. The different lights, different features, and the correct names for those features, just as a helpful guideline, maybe.
Yes.
Kind of a Solarchat standard.
Yeah, whatever.
I think with the CME term, if I'm right, I think that you can't see a CME unless you're in, like some of these very, is it like in the very far UV,
X-ray.
the SDO images, and also, from Soho, then you can see CMEs. I don't think that we have the capability and the wavelengths to see them. But I could be wrong. But I think the only parts that we actually see are either solar flares going off on, and you see them very, very brightly. And you might see some sort of like what looks like plasma, like being vented off. But I don't think we can actually see the actual CME. If we do see something on the edge, it's usually like the prominence, isn't it?
Yeah.
I think.
Yeah.
It's not to say that it hasn't given off a CME. It's just that we don't have the wavelengths to see it, I think.
I think most of that CME imaging is done from above the atmosphere and the extreme ultraviolet. So, and going back to the one piece that Nick mentioned about, photosphere versus the chromosphere, if you're imaging in white light and calcium K and hydrogen alpha. Personally, I wouldn't get too hung up in the description of it. Like, I would refer to it as the active region because they're all numbered.
Yeah.
This is the active region in white light, or this is the active region in H alpha, and not get hung up on whether you're on the photosphere or some layer of the chromosphere.
Yeah, and then when you're describing a feature, you're describing the umbra, the penumbra, and the other little bit of features, rather than sort of like generally calling it a spot. But then we all call them spots, don't we? Because there's the sunspot count in, like in an active region, and then also the sunspot count that we get, for the full disk, don't we? Daily sunspot count. But then that's a whole different count altogether because that's calculated in a completely different way to the actual number that you can see. And that always blows my mind.
Bob's itching to get in there.
I think you have to remember, and this gets into the weeds a little bit, is how our filters work. And they do not produce a square wave that's very narrow. They produce a transmission profile that's either Lorentzian or with double stacking, triple stacking, gets closer to a Gaussian. But they always have these tails that go off band. And so when you're looking at hydrogen alpha or calcium K line, you're never looking at a pure single wavelength. You're looking at a mixture of wavelengths. And the wider that tail is, the more photospheric light you're going to get. And you're going to see photospheric features like sunspots. Single stacking will show you granulation, usually in H alpha. Whereas when you narrow that, that was one of the first things I noticed is double stacking gets rid of the double limb of the photospheric light coming through. And you see a more pure hydrogen emission. And sunspots take on a dramatically different appearance. You lose the penumbra. You're centered mostly of the umbra shows. And I think if you got narrower and narrower and narrower, and I haven't seen any high resolution spectrographic images of, say, H alpha, you would see even less sunspot details. So I think that's a really important thing to remember is our filters show a mixture of wavelengths. And so you're always going to have some degree of photospheric features showing through until you get to a level of narrowness where you're then looking at that specific layer. And I think, Alexandra, you've had a chart, I've seen it many times, where it shows the altitude of the features above the photosphere, and it's arranged for the center of H alpha, the H alpha wings. Same with calcium K line, showing you the altitudes and temperatures of those features. And that's what I really think people should look at, as well as, again, realizing our filters do not make square waves. They make these Gaussian and Lorentzian profiles that allow a mixture of those frequencies to get through.
So yeah,
Lovely.
Nick,
Thank
don't
you.
get hung up about it.
Yeah. Yeah,
Yeah, no,
I
that's
don't
really
have a,
useful.
yeah, I don't have a
Sorry.
problem with somebody calling it a sunspot, you know, and
Hmm.
when they start talking like Stu talked about, well, here's a flare and you know it's a prominence, or here's an image of a CME and it's really just some plasma lifting off. I mean, those I'll usually, you know, try to kindly correct them and say, no, what you're saying is, you know, properly called a prominence. You don't see the CME. There may have been one, but and you're not seeing a flare in this case, but over here near the spot, that bright spot, that's a flare, you know, those types of things.
Yeah, I
Yeah,
think
it's helped me even to the question to have occurred to me, and then in typing it, and then in thinking about it since and what people might come up with, to just sort of fine tune it a bit in my mind. And certainly the snippets that I've heard from each of you, yeah, right, some insightful penny dropping moments again. And thanks, Bob. You know, that's really useful. So thanks for your thoughts on it, really.
Yeah. Matter of fact, Bob, I had a question regarding during some of my animations when I'm looking at mainly the surface and around spots, the fast movement around of, are we talking fibrils or spicules in that case, that, you know, they're rapidly moving?
I think they're fibrils, I think, aren't they?
Well, that's why I wondered. I know that some thicker ones will be referred to as fibrils, but I'm wondering also, are we seeing spicules that are doing the, just, you know, when you condense some, you know, 3 hours down to 20 seconds or whatever, you see these so fast moving, especially on the surface. I mean, they're easy to see on the limb, you know, the spiky, you know, spicules coming through, but on the surface, that kind of definitions, are we looking at fibrils or are we looking at spicules in that case, especially with a 60 millimeter like I've got?
Well, I thought they
You know
were
what I'm
one and the
referring
same.
to? It looks like hair on the surface of the sun.
I thought they were one and the same, like a filament and a prominence.
Well, I know the filament and prominence, but I'm talking about between
Yeah.
spicules.
So same definition, yeah. I thought
Yeah,
spicules were looking at it on the edge of the sun and the fibrils were on the surface, but I might be wrong. It's
Yeah,
happened
you
before.
see,
I can't remember when, but I was wrong once.
I thought I understood that like you get a filament above a prominence to the edge, that you've got a spicule to the edge, but a mottle above was how
right.
and a mottle's a teeny filament before it's a filament.
Oh, okay. There you go.
I think, I don't know, I could be mistaken.
I
sounds
think
like we
these
need
are
a
on my tree, you know,
Bob's
for
gonna check something.
yeah, because I read a paper somewhere and they were talking about different ones, and this is, you know, where I started writing, you know, like this little chart, and spicules are seen on the limb and mottles are seen on the surface, and then in a flare, like a non-flare active region, you've got fibrils, arch filaments, and if you're seeing them on the limb, they're like surges. They look like surges.
Yeah,
So I can show you that on the actual prominence chart that we're going to talk about later.
Yeah, typically I can identify surges, that are either face on or, to the side of a spot or active region. But there's, I don't know how else to describe it. If you ever watch a surface animation, you see it in everybody's, where it's just the rapidly moving way faster than any of the filaments, any of that, as to which feature that actually is.
But spicules, fibrils, mottles, whatever you want to call them, they're constantly sort of like pushing up
Yeah.
and coming
And
down.
coming back in, yeah.
Always, even on the quiet sun, roughly in a time scale of 5 to 10 minutes. So I have got somewhere I've written, the actual speed, so that they push up and they come back down again
Right.
every 5 to 10 minutes all the time. And so when you see like a time lapse, of the quiet sun, you see it sort of like waving like wind, like grass in the wind.
Right.
It's
Right.
this constant shuffle. And then if you were to actually do a time lapse of the limb, you see these spicules, coming up and going down,
Right.
like a little fluffy edge constantly. Because some people have got some really lovely animations, in high resolution, where you can see them pushing up and coming back down all the time.
I think there's a big difference between fibrils and spicules. And I go to my Bible, and it's probably backwards, at least it shows backwards. This is a book from about 1974, and it's the authority I use when I look at things like this. Now, fibrils are generally confined to active regions in the bipolar magnetic fields, whereas spicules are pretty much a feature of the general chromosphere, and they're all over. They're best seen off band, about 0.5 to 0.75 angstroms off band. And you see a lot of newbies, especially with mica filters, because they're difficult to judge when you're on band because of the temperature lag. And a lot of people who buy a brand new Quark or something who've never looked at the sun, it seems to show a lot more detail when you're a little off band, because you see all the mottles and rosettes and spicule activity that's off band. But when you get on band, a lot of that disappears. You'll see the spicules and what we call macrospicules off to the limb, but the fibrils look more like this. And this is the plates. I hope you can see that there.
Yeah.
Okay.
And these are limited mostly to the active regions and the magnetic fields that around the sunspots. So they are by definition different features.
Do they form and disappear rapidly as well, like spicules do?
Don't think so.
Let me see. I'll have to.
Because I know spicules, like Alexander said, they don't last very long at all.
Yeah, it's like this rosette that you go around.
Right.
So that's what they're showing for fibrils.
Okay.
Okay. And I'll have to look at their time frames, but from what I've seen of animations, I think they change fairly rapidly. Like, with the umbral, you can see in white light the umbral changes that are going on in a sunspot.
Right.
I'm assuming they on that time scale, minutes to maybe 30 minutes or something like that they'll change. But I'd have to
not show kind of a radiative motion out of the center of the active region away from the core, or at least I seem to recall seeing that in other animations anyway.
Yeah.
Which brings nicely into the question that Peter wanted to discuss, and that was the prominence classification chart, which sort of like grew away from sort of like a prominence classification chart, but almost into a classification chart of all of the features that you could see in the hydrogen alpha sun. And it just grew and grew and grew. So what I'll do is I'll share my screen and then we can have a look at this together. Just let me know if you can.
Just really quick, I've just read here, you know, they have the appearance of iron filings. Individual fibrils normally take the form of long, thin, dark streaks whose apparent widths are on the order of 1 to 3 seconds of arc. Links can go up to 15 arc seconds, and they usually last 20 to 30 minutes.
Okay,
Mm.
No, 10 to 20 minutes. I'm sorry, I read the wrong
10 to
thing.
20.
Yeah.
So
That's cool.
fibrils, Bob.
That's the fibrils. So I'm assuming the spicules are the ones that I'm like Alexander said, looks like grass waving because they go so quickly.
Yeah.
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 Okay.
Can everybody see my shared screen?
Yeah.
Yes.
All right, okay, excellent. So in the Solarchat main index, if we get there, okay, we have this is Solarchat, and then underneath it, I started this project it's probably about 2 years ago now, to be honest, but it was only like last Christmas, I think, that I really got my act together and got everything together. Now, it came out of this January Solar Challenge, which was back in 2023, to try and see whether we could label things up. Now, I'm wondering, have I got a picture of the full chart? I'm not sure I have, actually.
If you just click on one of the actual topics, there's a picture
Yes.
in there anyway, you can bring that up.
Now, you were talking about fibrils, spicules, and mottles. Okay, so I had classified them. Let's see if we can go in and it will show the whole picture. So I've got this whole picture, which I don't know whether you can see me. It's sort of like on 2 A4 sheets. Okay, and I've I click on that, does it show it bigger? Yeah. So we have the sun. Okay, and then we've got 2 branches of the tree. So we've got like the active sun and we've got the quiet sun. And in the small scale features that last 10 to 20 minutes, I've got spicules, which you see on the limb, which are these little thingies. And then we've got mottles, which are on the surface. Okay, but in the active sun, you're all in the way, so I can't actually see it. Can you see this side of the chart?
Yeah.
We've got either a flare
Yeah.
or a non-flare. Okay, so these are the fast moving things. So we've got the fibrils over here, which is part of the active region. So this is the fluffy ring that we see around it. Okay, is the fibrils. And on the edge, you'd probably see them as very fast moving spikes. And then we have like the arch filaments, which are in between the spots. Okay, which you'll see, it's a bit like the iron filings. So you'll see between the spots, you see these like arch filaments that go between them. And you'll see them as like little loops on the surface, but they'll be tiny. Okay, because the active region is quite a small region. And then you see these surges where you're constantly seeing these longer ones coming up and coming down. So that was my undertaking of those 3 things. And I think that's similar to what you said, Bob, was it?
I
Yeah.
think so. Although surges, I would classify more as prominences, surge prominences, rather than, the fibrils type events.
Oh,
But
yeah, these are larger
yeah.
coming out of the active region. So, yeah, you would have the small fibril. Yeah, this is one of the things, this is one of my discussion things, is that this prominence chart that I've done doesn't account for size. and is size important? And I think here, the difference between a surge and a fibril is quite different. It is the size is much bigger in a surge.
And there's been some charts of prominences I've seen where they basically classify them into two types: the active prominences, which are usually associated with some level of flare activity, and then the more quiescent runs, the hedgerows and things like that, that aren't really associated with any kind of flare-like activity. So
Yeah, so we've got this branch here, we've got the quiescent prominences. So this is sort of like over this side, and we've got the active region prominences over here. So yeah, so once you've got the active sun, you've got these quiescent prominences over here. So we've got filaments that you see, and they tend to be orientated in these sort of like slanting orientations. So these are the filaments, and then if you were to see them on the edge, they would be prominences. So then we have these attached prominences, and then we've got single attached, and we also have ones that appear not to be attached. So we've got like these floating cloud prominences where we can, what it looks like is they're quite stable, but they're just sort of like hanging there on the side. But actually, if you looked under high resolution, you do see that they do have these very faint anchor points. They're not technically floating. I think they're sort of like just suspended by these very small areas. But then we have that dispersion. I don't know how you spell it, pronounce it. Is it dispersion or something?
Dispersion brusque.
Brusque.
Yeah.
So this would be, that's probably not in the quiescent. I wouldn't have thought. It usually starts off as a quiescent because it's like one of these arch filaments, and then it suddenly becomes active. So it's sort of like nearly here, where it just suddenly lets go and just lifts off. And that can all, so it starts off as a stable prominence, and then one tether breaks and it just goes. And that can all happen within about 20 minutes. So that suddenly goes from quiescent into active, but it's not active as in associated with the flare. So there were all these different shapes and sizes and everything like that. But I had on here, if we go back to the main thing, I did have this discussion which I pinned to the top, and nobody's discussed anything at all.
Oh,
I
I missed that one.
I had these questions. You know, if somebody actually sat and studied this, because I'm not saying this classification is in any way perfect in any shape or form, because I've just come at it as in a fact that it just was pure wonder. And it's like, can we get this into a tree? Can we get this structured? Can we think of names and everything? Because you hear all of these things going around. But the classification that I've done it doesn't account for size of the prominence. So is size important, as is shape? I had sort of like, when I was drawing it, I was thinking this mound or cap that you see on the very, very edge. Is it actually just a solar flare going off on the edge? Because quite often you see these photographs of these beautiful mounds or caps, and they're sort of like perfectly formed in shape, and then they grow and then they sort of like disappear. So I was wondering, are they a stable feature, or are actually we just looking at, you know, the beginnings of a solar flare going off? And it's the same with a surge or a spray. Now, I think that I've sort of like kind of over the couple of years decided that maybe a surge and a spray, they are different. Surge is sort of like a longer than fibrils, and they come up and they come down. A spray seems to happen after you've had a big solar flare and you've had like that mound and cap. If you watch it, and I've seen this in many animations now, it rises up and then it just starts spraying out, I think somebody did a beautiful time lapse recently. It sprays out, and then that spray then comes back down and starts forming these beautiful loops. And then you get like the post-flare loops. So I think it's all part of the same active region thing, but it's just different time points in the scale. And somebody did like a beautiful start to finish, lifting up, going into a spray, and then starting to form the loops. If you can remember who it was, please let me know. It was only like a week ago, so.
Did
And
see
then,
that, and it was a gift too. So you can post that.
yeah. A
If
lot
I
of the curtains and hedgerow proms are similar, like to the pyramid, the tree trunk and flame. And I was thinking, are these just different orientations of the same object? So if you see them like horizontally, you see them as a nice quiescent filament. But if you see them turned round and you see them side on, is that where you're getting like the tree trunk and that sort of thing? So I was wondering whether this is just orientation. And many prominences have several classifications, all of the same prominence feature. So sometimes you see somebody has an image and it looks like there's lots of different prominences. Are they all the same prominence and they all show the same different features? So you call them a mixed, or are they just a line of sight effect and actually you can see one behind, one in front, and one to the side? So I think that as we get animations, it's easier to see that sort of thing going on. So another thing that Peter was saying is, can we go through one and say, like this one? I sort of like got together from the January challenge and just added them the images from the different people so that I could sort of like put together this January solar challenge and start to put them into categories. So we're looking at the Disparition Brusque event. I would say that that's one of those, definitely, from Bill. Wouldn't you?
It's
like
just
it.
hard to tell unless it's an animation, because
Yeah.
it could be something. I've had spikes like that continue, for hours, and then they may lift off. When do you call it a dispersion? But I mean, I call it a dispersion brusque when you see it leaving. So it's hard to tell from a single shot. Now, if it's, one shot and then another shot an hour later, see, that looks like that, I would
That
say,
does, yeah. Yep.
So
that
yeah,
would count.
it
That
looks
like one.
So we've got 1346. I'm presuming that's time, maybe. And then we've got 1411. So that's happened within what is it?
25 minutes.
25 minutes. So I
Yeah,
would say if you were to say that you've got a Disparition Brusque, you need to do a time series, don't you?
Yeah, and
Present it.
the question I'd have about that one is, did it leave or did it drop back down? Did it, was it basically reabsorbed? Because I've seen that happen too, where it reaches out like that, but then it spins back down. It's hard to tell. From the fading, I'd say it left, but it's still, it's a little bit further out in that one. So I'm guessing it is.
And then we had one presented from
That's Jim.
So he presented these. So again, it's difficult to know cause that's the 23rd, the 24th, and the 25th. So that's quite a slow going thing, unless this bit on the 25th started to break and lift off. But we haven't got any further. I don't know, we haven't got any further ones. So yes, in this, it's difficult to say whether it is. He says here it's an erupting prominence, so he must have followed that over time. But he's only shown the single shot. Usually
Right.
Jim does actually show the full sequence, doesn't he? This one is from Franco. Again, it looks like it's lifting off, but because we haven't got any continuation, we don't know. Here's one. Is this one from me? I think. Yeah, I watched this over a period of time, and it lifted off up here. So yeah, this just gradually lifted away. So I guess you've got to take the person's word for it that as they watched it, it just disappeared.
Yeah.
And it's the same with this one. Again, it's like a stable quiescent prominence, and then it starts lifting off at one corner and then just lifting away. And then it looks like we've got one from Stuart. So again, just a single image. So this is no critique of anybody's images, but I'm guessing that if we want to, we need either time lapses or we need a sequence rather than just single images for this section, I think.
So, sorry, Alexandra, just a quick one then. There's Solar Viewer, where we could look at NASA data or whatever, ESA, and look at these timestamps and then look at the feature using the satellite data, and then you can look at animations from the satellite. So that would then fill in the gaps, wouldn't it?
Yeah.
So say, okay, well, this is what we saw as amateurs. What actually did it look like? Because it's difficult to do animations. Sometimes you get cloud cover or whatever. And at least that way we can then properly classify these.
Yeah, and even if you look at gong, you see the gong animation, you'll see whether it's lifting off or not.
Yeah,
I'm looking at the Zirin chart, for instance, which has been long the standard for a lot of these features. And my first assumption looking at something like the Zirin chart is that's a point in time. So we're not necessarily the whole animation of what happened, because it started as a certain type of prominence and then it became a dispersion brush. Whereas looking at Zirin, that just tells me that at a point in time when you were making that observation, that's what the particular feature was. So what's more important, the development of what it became throughout an animation while you were watching it, or the fact, because a lot of people don't do animations, obviously, they just take images of the sun. So at a point in time, is that what's more important, that actual point in time, this was very clearly a dispersion brush because it was completely separated from the sun, whether it fell back down towards the sun or whether it drifted off at that point in time when you took that image. And that's what I think I'm getting at. Is that more important than looking at what it began as and what it became and what it ended up as? If that makes sense.
There's a nice one from Warren.
Yeah.
That's one of my first ones.
And that's brilliant because
It is.
you can follow the development of that. But if someone was
Yeah,
just taking an image of that now, say about now, then clearly that's a dispersion brush. But if
right.
they had taken an image of it, minutes, half an hour ago, it
Yeah,
was
right at
still
the start.
attached to the sun. Yeah, and so did
I-
it classify as something different?
Yeah,
that was like over an hour and a half.
Yeah, yeah. Um,
that's nice that we've got that, and that's the end of that particular one.
Yeah, I wish I had posted that. I took a full disc shot of that at the end, and that thing was still visible. It was probably, the bottom of it was probably about 200,000 kilometers above the surface, and it stretched out another 300,000 kilometers out of there. I mean, it was humongous.
I guess the other question from my point of view is once that's clearly moving away from the sun and dispersing. So um, if it were just to, I mean, I don't know how long it could probably stay in the same position. Is it just constantly going to be moving away from the sun, or because we talk about clouds as well, so the floating clouds above the sun. So are they one and the same thing, for instance, or is there two different classifications because one moves away from the sun, and the other stays within the region that it came from, but just above the sun.
So a floating cloud is very quiescent, and they just sit there and they hang. And so we get them like this. You'll just see it and it's not moving away and it just sits there. And it looks like it's just there dangling around, not going anywhere. But actually, if you see, there are these very, very fine attachments holding it on. And it's probably coming down here
Yep.
as well. So
See
they're stable. They won't go up or they won't go down. They'll just
yeah.
there. But sometimes these very fine tendrils do seem to snap and then they just drift away.
One
So I
of the
don't,
things I've noticed with Jim's pictures, sometimes he does, and they're really fantastic, and it may be important on whether you're deciding whether this is attached or detached, is you have to look off band. Because when he's tuned his, I think he has a T scanner on his Daystar. When he tunes off band, you'll often see things off band that you can't see on band. So you don't necessarily know it's completely detached because you're not seeing any kind of Doppler shifted materials that might not be showing up when you're on band. So just for what it's worth.
Yeah.
that's another interesting slant. Thanks.
Yeah, the what you've done, Alexander, is quite amazing, to be quite honest, because um, it it certainly makes you think about what you're looking at, and that's what I think is the real value, that one that we can contribute to and add the images to it. But it really, and I've started to do this very recently, to make me think about what it is that I'm seeing, and referring back to this classification chart. So I'm just wondering what we can do to develop this further, how we can where can it go and where should it go? Because again, I think things like the Zirin chart and those charts are probably, while still relevant, they are probably they don't take into account that amateur astronomers, solar astronomers now are doing animations and getting um, a lot more information on these features that we see on and around the sun. And and as we've mentioned, a lot of those are done with animations, and so things will change over time. So is who is it important to besides us? Is it important that maybe we can develop something like the Zirin chart further than what it is to take this into account? Or are we trying to as you said before, a lot of these features may be the same. It might be just the angle we're viewing them, or a line of sight or something like that. So I'm just wondering how we can further develop this, because I think it's fantastic what you've done.
Well, it was like a first pass attempt. And everyone can sit and have a look through all of these things. People can make their own judgments because, in some of them, like the pictures, the prominence is really, really tiny. And some of them are really, really huge. And as I started to go through them, I was thinking, gosh, this is just getting more complicated than actually just a chart. Because like already today, we've discussed that there's time in the section, there's size, there's off band. So what is like the Doppler shift like? So there's all of these different orientations. So instead of it just being like, when we look at things like a picture 2D, we're actually looking 3D and 4D if you include time. And then we've got a fifth dimension really when we're looking at all the way through the hydrogen alpha and in the wings. So it's not just like a flat project, but I wanted it to get it all together because I was trying to get it into my head. You know, what are we actually seeing? It's a bit like Nick. I had this fascination of what am I actually looking at? And when you go through like all of the web, you get little bits here and you get little bits there. And you virtually have to go through about 10 different books. And each one's show different things. And it was like, it would be nice to sort of like get everything all together under one roof. And then I was thinking, well, Solarchat has hundreds every day of all of these examples. If somebody had, you know, like a great example of something and they added it, you know, to the actual section, then immediately you'd start to grow a huge bank of all of the different varieties, because it's like every single one of them is different, but they all have the same theme. So you start to get, it's almost like like, unlike, you know, like the Galaxy Zoo, but you're getting like the Prominence Zoo, and you're getting to see many examples. And then it means that any beginner or new person to the sun, or even if it's, you know, like a seasoned person can come to, there's like a bank of images that they could look through and try and get an idea of what they're actually looking at. So it was more like an encyclopedia. But if we ever got to getting it to a great wealth, then we could publish it. And certainly, you know, like in the British Astronomical Association, they have like a journal which we could pool our resources together and actually sit and discuss, you know, in, you know, the paper, say, what are we actually looking? Is size important? Is time important? You know, all of these different things, and actually bring it and get it published and have, you know, like a better chart that's out there that hasn't been produced before. So that was kind of my idea.
Alexandra, I think that's a wonderful idea. And if you could, you know, refine your chart with some of these images that have been captured and send them to Christian right away, because he's revising his book. And I'll just show you that the only thing that's in his book right now and what I've seen on the internet are these.
Yep.
Yep.
And they're very basic and not as detailed. And what you've come up with is fantastic. And I think I'd love to see it in Christian's book, which is, you know, the de facto Bible right now for solar astronomy, as well as, you know, Alpo, the BAA, and all of that. Get it out there. It's wonderful.
Thank
That's a
you.
great suggestion. That really is a great suggestion. And I think that's the place for it.
Yeah, because it's sat here for about a couple of years and nobody's really ever contributed to it. So I was
Yeah.
thinking it was kind
Right
of
on the
dead if
cover.
nobody was interested.
Have them put it on the cover.
So yeah, it's I still have loads of questions, you know, like I could just sort of like chat about it for hours, you know, and go through I'd love to sit and just go through every single image that we've got on here at the moment, and then just say, you know, like with a team of people, what do you think this is? Shall we recategorize it and put it in another? Or should we recategorize it and put it in another? Because, you know, there's certainly so many different varieties. And there are also some which have got none at all, like down here, which even I didn't have any pictures of.
Do
So
you have Christian's email address, Alexandra?
no. Oh, yes, I do. Yes,
Yeah.
Okay.
yes, I do.
If you don't have it, I'll send it to you. But I would I'd send him that picture and get it to him immediately and get his interest picked.
Isn't Christian online?
He just
'Cause I'm
logged
sure
off
I
for some
He
reason.
was.
I'm sure I admitted him.
Yeah, he left.
Oh, did he?
Yeah.
All right, okay.
It must have known what was coming.
Oh dear, put him off straight away. So yeah, like on the spicules, I haven't got any high resolution images, but I know that some people like Banjo and some have amazing pictures of spicules along the limb, you know, like because I just can't get that. So I haven't got any spicules. I did have a go, you know, I've got one of the mottles that I've taken. But again, you have to do these, they're better to see off band. So this is like an off band image. So you get these different ones. And like certainly if you, I think is it in the blue wing, you tend to get these doublets. So you know whether you're in the blue wing is if you've got these little doublets, like you can see here.
Right.
That's a characteristic of whether you're in the blue wing or, and you say see singlets if you're in the red wing. I think that's from the Zirin book. I learned that. So yeah, if anybody's got pictures, you know, like of mottles, that would be lovely as well.
Are those with your DSF 100s?
Yes. So, and it's also much easier if you've got a day star, quark or something like that, because if you keep imaging as you're warming up, you can see like the blue wing spicules, and then they gradually turn into not spicules, the mottles. You can see them gradually come into view when you actually get away from that white lightish bit on a cold quark, and then as it gets warming up more towards like the on band, you can see these, and then you can also then carry on and go into the red wing as well when you've got, you know, like this is what Ken Huggett told me anyway, that when you've got a normal echelon, you can only see in the blue wing. You can't see in the red wing. You can only see in the red wing if you've got a heated mica echelon. So if you've got one of those, it would be great if you could add to that.
Or you can have a Coronado Etalon that's usually generally really high in the red wing to begin with, and then you tune it into the on band, and then if you go farther, you might get into the blue wing. But the Coronados are typically band high in the red wing.
Yeah, it's funny because Ken was saying to me, no, because I was thinking that if you tilted, you started off in the blue, you tilted into the central line, and then you tilted off into the red. And he said, no. He said, with the solar scope, you'll be in the blue wing, then you'll go on band, and then you'll go back into the blue wing again. I could never quite get my head around that. But that's what he kept explaining to me all the time. And I don't know.
Now, typically on a tilt tune Etalon, they're off band high. And as you tilt it, you go further blue. And if you go off band after giving more tilt, you're in the blue wing. But you get, with too much tilt, you get all kinds of banding and stuff because the wavelength shifts across the filter become exaggerated. But the Coronados that have come out from Mead, especially with their rich view tuning, are generally tuned way, way high. And that'll be the red wings of H alpha. And then hopefully you can get into on band without getting banding. But yeah, now the pressure tuned Etalons, they're blue. And as you add pressure, you shift them on band, and then you can go past that in the red. So the pressure tuned Etalons, typically, if they're centered in the middle of the pressure range to be on band, you could go either blue or red with them, depending on too low a pressure will be blue, the right pressure is on band, and then higher pressure takes them to the red.
Yeah, you can definitely do that with pressure tuned. So this is one of these questions of how small can you be? Because this is a tiny, tiny weed prominence, and yet it's classed as a hedgerow in here. Now, would you class that as a hedgerow, even though it's tiny, tiny? That was one of my questions, because like you look at this and it's like a classic hedgerow, isn't it? You've got many multiple points and it's massive, whereas this one is absolutely tiny,
Well, like
but
a
it's
bush.
still got these multiple little points. So this was one of my questions of size, which was interesting. You know, like that's a classical. And here you've got like a hedgerow. Now, is this part still part of this? Because you can see
Yeah.
it's sort of like going over the top. And is this, or is this another little one on its own? It's difficult to get orientation. And then we've got another one. These are all classic. I think everybody can get a hedgerow. I think that there's not an awful lot of things that you can go wrong with one of those, to be honest. Actually. So some are easier than others. Tornadoes, I know I've seen some wonderful animations of tornadoes. It would be lovely to get them in there. Again, tornadoes, really, you need an animation to be able to work out whether it's actually rotating. I don't think you can do that with a static image, to be honest. Oh, polar crown filament. They're lovely. But I'm not sure that we'll see them now. Because as you go through the solar cycle, probably about now, and when you get to the solar max, they disappear off because they gradually migrate down through and then disappear. And then don't they start, when the cycle starts again, when the new cycle starts, you start seeing them at the equator again and they start migrating down again. So I think that we might be at a point where we don't see those too often now. Oh, have we only got two? I'm sure I've seen many, many more knocking about from people. So yeah, there's loads of different ones here. It's like pyramids. I'm sure pyramids are easy as well. So you get these flat sheets that here. So they don't have the multiple points, but they're sort of like these flat curtains that you see. See, that's a funny one. You've got a pyramid, but what about this bit here? I don't know. But they're quite nice, aren't they? So everybody can seem to get a pyramid too. So they're nice. So we have lots of examples. Oh, and we've got one from Stuart here. So that almost looks like a raised pyramid above the surface because it does have an anchor point here and an anchor point here. So would you class that as a pyramid or would you class that as a hedgerow? I don't know, or an arch.
Or an arch.
Maybe.
Definitely an arch there, but yeah, I think you could.
Oh yeah,
several
there's
ways you could
something
go.
that I haven't added into this is these bubbles. Yeah, I need to add in, you know, like you get these plumes, these bubble plumes that go up. Must get that into the classification project, I think.
Yeah.
But I don't know
Jim's,
whether that's a classification or whether that's just a feature.
I think a feature because Jim had talked about those, and he and I had shared some images back and forth of plumes, you know, rising up or bubbles happening in. Well, you've got curtain prom bubble down there.
Oh yeah.
Yeah.
Oh, so maybe I did squeeze it in. Have I got it on the sheet then?
Yeah,
I think
you do. You do, Alexander.
Oh, I do. Yes, I have. I've
Yeah.
already gone there. I must have revisited that at Christmas when
Yeah.
it did. So I have actually added. Yeah, you're right.
Yeah, Jim had brought that up, I think.
Yes, and I wanted to include it because, you know, like you get these voids and they just come out, and they're very, very interesting. You know, these
That's a
lovely.
good.
It
That's
is.
a good.
Yeah. And they just you can see them in an animation just sort of like coming up.
Yeah.
Fantastic. So yeah, there's lots there, and it'd be lovely if you could contribute really. And email me or PM me, and I'd love to have discussions with people about it because I just find it really fascinating. So I'll stop sharing there, and then we can see everyone again. So yeah, if you want to take this forward, I'm quite happy to take it forward if people are interested in it and find it helpful. That's the thing.
Very,
Mm.
Okay.
very
So,
helpful.
yeah, definitely.
That's quite encouraging to hear that people do think it's helpful.
Yeah.
Well, I think getting into the solar astronomy book was just a brilliant idea, Bob. I think that because clearly that's going to be revised every few years, I would say, by the look of it, as time changes and techniques and so forth change from amateurs. And clearly that would be a great project or a great chart. It could take up two pages.
Yeah.
Christian is quite connected to professional astronomy too. He does a lot of work with professional observatories. Might even get some interest from some of his more professional colleagues in working on that, Alexandra. And you guys could write a paper, you know, get yourself published.
Yeah, because it is something that I really love. Obviously, all my sketches are not that great. I was thinking, you know, like if I was to go further with it, I would ask somebody, you know, like Marius, who's like a fantastic, you know, artist. I was going to sort of like get some really nice examples, you know, from these images that we collect and say, Marius, could you sketch this for me so that we had, you know, proper, what I say, proper artistic sketches, because mine are sort of like little stick things, aren't they? You can kind of get the idea of what I mean, but they're not, you know, like artistic, are they?
I'm gonna have to bail, everybody.
Okay.
All right, see everybody later.
See you,
See you,
Brian. It's
Brian.
lovely to have you.
Bye, Brian.
Happy Thanksgiving.
Yes, that's where I'm heading to. Thanks.
Yeah, I've got to go as well, guys.
Okay, yeah, well,
Great
we'll draw
session.
this to a close, so
Yeah.
because it is 8 o'clock, so it's
Let-
been
let-
lovely it's
Can
been
I- can
lovely
I-
to see everyone.
Can I jump in?
Yeah, sure.
Yes, sorry, I was in and out because I'm trying to see the comet and it's really bright. I have a few
Really?
images here. Really,
Really?
really bright with a long tail. But for
Oh.
me, I have clouds here. But it's really amazing. It's
Oh.
it survived perihelion
Mm-hmm.
and it's really bright right now, about magnitude 1 or something like that.
Really?
So you should try to see it.
Okay.
Maybe tomorrow, after tomorrow, if the weather cooperates. It's always, I don't have any clouds, but now it's really bad here. But I can show you some images if you want.
Yeah.
Taken
Yes,
a few moments ago.
Just let me let you share. Okay, you should be able to share now.
So you should be able to see it now.
Oh, yeah.
So this was taken with the sea star in the south of Portugal. But for me here, I'm not able to see it. It's about 5 degrees up. And this one, it's amazing also.
Oh, wow.
So it's really bright.
Oh.
So you should try to see it.
I wish
try
I
and
could
get
have
it this
seen that
week.
yesterday because, you know, like we had a superb, you know, like low horizon, but it was just cloud all
Yeah, for me it's like this here at my observatory. So I'm really unlucky because all the clouds are close to the horizon.
Yeah.
That's what I had last night.
And it's totally clear and clouds at the horizon.
Oh,
Anyway, it's unlucky.
That's cool.
But it's really I tried before sunrise and I wasn't able to see it, but now it should be better.
excellent.
So
Great.
it should be a fantastic spectacle.
Brilliant.
Anyway.
Okay, so I'll draw this to a close, and it's been lovely to chat to everybody, and thank you very much for your input and encouragement as well, because you know, like I had sort of like thought that it wasn't very interesting anymore, and that's why nobody had gone on it. So thank you very much for that. And it's been lovely to see you. Okay.
Thanks, Alexandra.
Take care, all.
Bye.
Take care,
Bye.
everybody. All the
Bye.
best. Cheers.
Bye.
Bye.